All right, what do you say? Today and tomorrow, I'm going to introduce you to a special right triangle. Two special right triangles. One today, one tomorrow. And you'll see why they're so special. Anybody want to take a little moment of silence right now, where we should be at this exact moment in time? No? Taking our midterm right now? That would have been today at this time between 1 and 3 o'clock. Yes, I know. Devastated, but we're all here together. All right, we're so sad. Anyway, moving on. What I'd like you to do, this is going to be group work first. Number one only. Number one only. You'll see that I have a right triangle ABC. I have two congruent sides. I'd like you to figure out the other two angles for me using your geometry knowledge. Find the other two angles. AB, I think, is pretty easy. And then, do you have anything that could find the hypotenuse now? AC. In simplest radical form, if anything comes out to be radicals. So go ahead, discuss it with your group. I think you have more than enough knowledge to fill in all the missing angles and sides for problem number 1. Okay, so discuss it with your group, and I'll call on somebody here in a second for all these values. So find the missing angles, AB, and that's an easy one. And then how do I find AC, the hypotenuse, in simplest radical form for everything? All right, talk it over. You guys have more than enough knowledge.
Obviously, both sides. And that BC is 5, which means 50 equals C to the second. 25 and 2, so 5 radical 2. Oh, 25 and 2, sorry. No, that's right.
Angles and isosceles.
No, it's just 90.
Quickly converse with your group. Make sure you're all on the same page as far as these answers go. Okay, here we go. What was BAC and ACB? What were those angle measures here? Talk to me. 8.
45 and 45.
Correct. Both angles were 45 and 45. Perfect. I'm not even going to ask anybody. AB was a length of 2. And then how about AC in simplest radical form? Let's hear from somebody new now. 21, simplest radical form, AC? Not here. No, no, no. 13? 2 square root of 2. Hopefully all of you did Pythag to find that, and it came out to be 8, square root of 8, which breaks down, yes, into 2 square root of 2. Any questions there on those values? All right, go ahead if you haven't done so already. Number 2, find all those values now, please. Number 2. Angle ABC in that one. Angle ABC is 4. 90 degrees. It's a right angle. Good job. How about side BC now? Side BC. Let's go 20. 5. Remember, across from congruent angles are congruent sides. And then using Pythagorean theorem in simplest radical form. How about AC? 5? 5 radical 2. All right. I'm having you do these 2 examples because I want to introduce you to your first special right triangle. What do you notice about the angles in both? Okay, let me rephrase that. What are the angle measurements in both triangles? 45, 45, and a 90. That is your first special right triangle. All right. In a 45, 45, 90. I know the mathematicians are clever, right, when they name these triangles. And a 45, 45, 90 triangle. And again, those represent the degree measures. You guys probably see a pattern, don't you? You see a pattern. Number one, what do you notice about the legs in a 45, 45, 90? Legs are congruent. Now, I don't want to have to do pi fag every time. I just want to come up with a rule for the hypotenuse. I don't want to have to do pi fag every time. So can we say the following? The hypotenuse, HYP, is equal to, anybody want to give me a little formula so I don't have to do pi fag every time? How can I find the hypotenuse pretty darn quick every time? Tammy, what's up?
I mean, I don't know if this is true or not, but like the legs and like radical.
You take the leg, keep going, and you multiply one of the legs by, there you go. And every 45, 45, 90 triangle we do, that's how you find the hypotenuse. You take the leg and multiply it by radical 2. And this is where we're going to stay today. Tomorrow I'll introduce a new special right triangle, but this is where we'll stay in the 45, 45, 90. Questions? So we're going to start easy, and then the algebra is going to get a little tougher as we go on today. Any questions on the 45, 45, 90? All right, so let's keep working with it and see when we come into some problems. All right, so this first one, find all the missing sides for me. No pi fag, I don't have time. So here we go. Leg BC is going to be 6. Yeah, legs are equal, remember. Legs are equal. Hypotenuse AC, we do not need to do pi fag anymore. We can just use the rule that the hypotenuse equals leg times radical 2. So it's going to be 6 radical 2. Basic. Any issues before we start? The algebra gets a little, I need your help from last year, or even if you did it last year. So for 2, let's start with leg AB. What's the length of leg AB? Square root of 5. Everyone's good. Legs are always equal. Now, let me slow everything down now to find the hypotenuse. Still use your rule. Leg times what? Look back at your conclusions, you have to. Leg times radical 2. Now, if this was yesterday and I put an addition symbol between them, you can't add them, right? Because what's underneath needs to be the same to add them. But since we're multiplying, anything goes. You can multiply any radicals no matter the number underneath. So we can combine these into the square root of 5 times 2. Square root of 10. You can't add them, but you can multiply them. Okay, square root of 10. Questions from you guys? Stop me now, because the radical algebra is going to keep getting a little bit more heavy. Next up, BC is 3 radical 2. AB is also. We'll just get the legs out of the way since they're always equal. Ooh, what about the hypotenuse here? So follow the rule. Follow the rule. Leg 3 radical 2 times. What's my rule say? Radical 2. Now that I'm going to help you, how do I take care of this? There's a 3 out in front, right? You can multiply the numbers out in front. 3 times 1 gives me 3. Times, anybody remember yesterday's class? A radical times itself. A radical times itself. Anybody remember from yesterday? I think we talked about it on one of the problems. A radical times itself. So radical 2 times radical 2 is just the number underneath, or that's radical 4, which is square root of 4? 2. So this ends up being 6. Okay, everyone see how that worked? Desperation mode. You could use your calc. It'll give you 6 too. All right, desperation mode. Any questions here? Oh, look at me now. Now Everything was nice because I gave you the leg. What if I start with the hypotenuse now and go backwards? Some of you may see what the answer is already, but I'm going to do it all out in case you don't see it. What's the rule we wrote down in the conclusion? Hypotenuse equals leg times radical 2, right? That was the rule we used. Well, what's my hypotenuse now? 8 radical 2. Plug it in for hypotenuse. 8 radical 2 equals, put whatever you want here, x, L, whatever variable you'd like. I'll keep it L for leg, times radical 2. What do I need to do with the radical 2 to get the L by itself? Come on now, dig deep. Divide both sides by radical 2. And what happens to the radical 2's there? See ya! They're gone. So one leg. And I know a lot of you could have just been like, oh, you know what I'm going to do? I'm just going to take the radical 2 off, and there's my leg. That's fine. But what if there's not a radical 2 there? We're going to have to know how to set this up. All right, just like there will be in the next problem. So yes, the legs are 8 radical 8, which was what? BC and AB. So again, what if it's not a radical 2 and you just can't pluck it off like the next one? It's just 6. And look, I get it. I heard from period 2 already. We just did this one a couple ago. All right. Can we pretend we did it and we don't know the answer to the legs? Like what if the number up there was 16? Okay, we're still going to have to know how to do it. You can't just take the radical 2 off like the last problem, right? But I know I have a rule that says hypotenuse equals leg times radical 2. Plug in the hypotenuse. 6 equals leg. I'll just keep it L. Radical 2. Again, how do you get rid of the radical 2? How am I getting L by itself? Moving. How do I move the radical 2 over? Divide it out. All right, now here's where we got to talk, so you better focus up. You can't divide those. Don't even think about doing 6 divided by 2, right? Because that's underneath the radical and the 6 isn't. Go ahead, try your calculator, but you're going to get long decimals, which I don't want. So you're stuck right now. Okay, we're stuck. Anybody remember last year in algebra? Why this is not going to be an acceptable answer. And no, I don't want the decimal answer. Okay, don't want that. Can't divide them. Anybody remember last year in algebra why this is unacceptable? Come on. Somebody in period 2 knew. Don't let them beat you out. Why is that not Jonah?
Can it be simplified?
Well, we are going to simplify it, but why do we need to simplify it is the question. What's wrong with that answer? What's wrong with that answer? 6 over radical 2. Serena?
A radical can't be in a fraction.
Oh, radical can never be on the bottom.
It can be, but not in the... Use your big boy word.
Decimeter?
Oh my God, Christ, I'm out. Not decimeter. Decimeter.
Oh,
Decimeter. Denominator, yes. All right, yes. Oh my God. No radical in the denominator. It's okay if it's in the numerator, but not in the denominator, all right? All right, well, that's half the battle. The next battle is how do you get rid of it then? If I'm not allowed to have it in the denominator, what do I do to get rid of it? Out of there. Jonah?
Can you multiply the fraction by radical 2?
Need it by more, though. I can't do this. I got to multiply top and bottom by radical 2. I multiply top and bottom by the radical I want to get rid of. Now, because you're in honors, why is this okay for me to do? What is radical 2 over radical 2? 1. If you multiply anything by 1, are you changing its value? So this is why it's okay. All right, I'm really multiplying by 1. All right, so how does this help me? Ready? What do I get in the numerator? 6 times radical 2. 6 radical 2. And then what happens in the denominator now? Radical 2 times itself, which we just talked about is going to be what? The number underneath. 2. Perfect. Is there a radical anymore in the denominator? Oh, good. That's why. All right. That's why we do it this way, to get that radical out. But it's not going to be your final answer. One more step. It's not simplified all the way. Why not? What can I still divide? 6 and 2. Yep, 6 and 2. So my final answer here, each leg is going to be 3 radical 2. 3 radical 2. Cannot have a radical in the denominator. Don't leave it. Anything from you guys before we get to this last one? Okay, final one. I got a square. One of the diagonals is 10. What's the perimeter in simplest radical form? Why did I pick a square in this case? Well, let's think about it. What do you know about the angles of a square? They're right angles. And what do the diagonals do to your angles? Bisect them. So really, what type of triangle am I creating here? Isosceles more. What are we talking about today? If I cut a 90 in half, this is a 45, 45, 90 right triangle. Everyone see where that came from? I used my properties. Right angles in a square. Diagonal bisects the angles. All right, if I'm going to find the perimeter, I need to find a side length. So let's use our rules. Look at my 45, 45, 90. Hypotenuse equals leg radical 2. Your hypotenuse is 10. And I know there's probably other ways you guys could think about doing this. Maybe drawing the other diagonal and they bisect each other and you could do Pythag. I get it, but I'd want to do the 45, 45, 90. Clean that up for me. Can you solve for L now? In simplest radical form, can you solve for L? So divide both sides by radical 2. Get the radical out of there again. Let's see if we come up with all the correct answer here. No radical in your denominator. How's it looking? 5 radical 2 for the leg. Anybody? 5 radical 2 after you simplify and multiply top and bottom by radical 2. Whoa! I didn't answer the question though, did I? Perimeter. If one side's 5 radical 2, any ideas how you want me to get to the perimeter? Yep, Tammy.
5 radical 2 times 4.
Multiply it by 4, or you could add 5 radical 2 4 times. So 4 times 5 radical 2. My perimeter here will be 20 radical 2. All right. No denominators, no radicals in the denominators tonight. Okay? It's right in the packet. You don't have to go back to the book tonight. All in the packet. Good work, good work, good work. Friday. Stop in if you need anything.